Okay, does somebody want to say the opening prayer?
I'll say
I
it.
can say it.
Okay.
Or you can go ahead.
Okay. Our dear Father in heaven, we're thankful that we can come together as a class. We pray that that will help us to learn and grow together. We pray that that will help us to feel the Spirit and to understand the new concepts that we are learning. In the name of Jesus Christ, amen.
Amen.
Okay, so does anybody have any questions on the preparation assignment?
No.
I was having a hard time figuring out how to make pie charts.
Yeah, that took me a little bit to get it figured out for the class survey.
Right.
I had to count how many were in each group and then make those my numbers for that.
Okay. So you just have to turn everything into numbers.
Yeah, so I took everything and put it on a different I made a completely different table. It made it a lot easier.
Okay, I'll do that.
Yeah. Okay, so any other questions?
No.
Well, sweet, let's move on to the group quiz. So everybody pull that up. Let me know when you guys have it up.
I have it.
Sweet.
Lesson 16?
Yes.
Okay.
Mm-hmm.
All right, I have it.
Sweet. Kelton, how you doing?
Sorry, what'd you say, Tyler?
What's up?
I just said, what did you say?
Oh, I said, Kelton, how are you doing?
Sorry. I'm ready. Sorry.
Wait, no, it's fine. Okay, let's answer the first two on your own. So number 3. Well, information, you're required to work together, submit your own answers, or receive credit. If you need it, here's a link to the normal probability applet. When calculating anything, please remember to round to 3 decimal places unless otherwise specified. Do not round until your calculations is complete. Okay, so number 3, in a pie chart, why are slices, sectors different sizes? Okay, the size of each slice is random? No. The size of each slice is determined by the number of categories? No. Each slice represents a category, and the area of each slice represents the proportion of the total occupied by the category.
I think that's it.
I think that one is.
I would say that one.
And it's funny because it's the longest answer.
I think that's how they do it sometimes. Sometimes they kind of give it away.
Yeah.
It's funny. Okay, how are bar charts and I don't know how to say that word, but I'm going to call it Pareto charts related? I'm going to guess the last one because it's a long one. The only difference between a bar chart and a Pareto chart is that the bars in a Pareto chart are ordered largest to smallest, going from left to right.
That sounds right.
Yeah.
Yeah.
So let's move on to number 5. Use the following information for the next 3 questions. We conclude that the sample proportion is normally distributed if NP equal to 10 equation. The true proportion, is the P the true proportion or the sample proportion? proportion?
Let me look at my notes really quick.
I want to say it's the sample proportion or the true proportion, but yeah, I'm not positive.
Sorry, my computer's slow.
No, you're fine.
I want to say it's the true proportion.
Me too, because
Yeah,
it doesn't have a little p,
Yeah.
little squiggle above it.
Yeah,
And the one with the squiggle above it is the sample portion.
right.
That sounds right. I'm going to check though. Okay, so what I have is P is the true proportion, and P with the, I don't know what you want to call that. It's not a tilde.
Caret.
Caret, thank you, is the sample proportion.
Yeah, so let's say
Okay.
let's go with true proportion.
Okay.
Okay, so number 6, what is n? N is the sample size.
Yep.
Mm-hmm.
Okay. Number 7, if p equals 1/4, what is the smallest n that satisfies the requirement? Let's see.
Well, do we divide 30 by 4? Is that what it's supposed to be? I don't know.
I don't know.
Let me get my textbook up.
I thought you just divided 1 by 4, but I'm not
Yeah, so it'd be
confident
1
on that.
minus 1/4, and 1/4 could be translated into 1 divided by 4. So it's 1 minus
So
0.25.
that's 5. Do we add a 0 on the end?
So it's with this, the smallest, so it's 1 minus 0.25.
Yeah.
So
Oh,
is
oh.
that 0.7?
So it basically, yeah, so 1 minus equals 7.75.
So the answer is 0.75?
No, that's not the answer.
Oh, okay.
I'm confused.
I think it's more like 13.333.
Okay, so we take 1 minus
Okay,
what?
because so it's 1 minus the 1/4, and 1/4. So you could just divide 1 divided by 4 equals 0.25. So
Right,
it's basically 1 minus 0.25,
which is
which
0.7.
equals 0.75. And if you just take, because we're saying this one is greater than 10, so if you just take 10 divided by 0.75, and you get 13.333.
Okay, so 13.333.
Maybe. But you want it to be greater than 10, but that would equal 10.
Oh, okay.
So if we did 14 times 0.75, we get 10.5.
I see what you mean.
So 10.5.
Yeah. But I don't know how much.
Can we, if n equals the sample size, can't have a half a person, can we?
I don't think
I
so.
don't know.
Well, I don't know if, or can we have half of something?
I see
I
in the
don't
formula says if the sample size times the proportion is greater than or equal to 10, and if the sample size times 1 minus p is greater than or equal to 10, you can conduct probability calculations with the applet. It's at the very end of the chapter.
Oh, okay.
Do we have a formula for sample size in this chapter?
I think there's one.
Maybe not.
I don't see one in this chapter.
What's for C and P?
So,
Okay.
what is the 10? What does that represent?
Okay, so at the very beginning it says, if you toss a coin n equals 25 times, you keep track of the proportion of heads you observe. In this sample, we tossed 12 out of 25 times. We had heads 12 out of 25 times, which is equivalent to a 0.48 proportion. So 1 out of 4 means that we've tossed it 4 times and we got a P once. So out of 12 out of 25 means that they tossed it 25 times. So 1 out of 4 means they tossed it 4 times.
Yeah.
That's what I think.
And then, yeah, and then when
24?
you divide,
If they're just simply talking about a proportion, 1 out of 4 means that they had to at least toss it 4 times. Does that make sense to anybody?
Yeah.
mhm.
And that's the best guess I can give.
Four makes sense to me. What do you guys say? 4?
Yeah.
Okay, awesome. So we'll move on to question 8. Suppose n equals 24 and p equals 0.4. What is the mean of the sample proportion? That is the same as p, so that's 0.4.
Okay.
What is the standard deviation of p? Okay, so this one is,
Oh, the formula.
yeah, it's the square root of this little equation thing. So p times 1 minus p over n, and then you take the square root of that. So let's see, what is our p?
Our P is 0.4.
0.4?
Yep, 0.4. Our n is 24. So we do 0.4 times 1 minus 0.4, 24. That gives me 0.
Sorry, you're breaking up.
So I have the equation 0.4 times 1 minus 0.4, and that's divided by 24, and that gives me 0.01, and then the square root of 0.01 is 0.1.
That's what I got too.
So that's my standard deviation. Okay, and then number 10. Brittany's batting average is .300. We want to determine the probability she will get more than 35 hits in her next 100 at-bats. So now we have n equals 100. It wants to know what is p, so, or the sample proportion.
Okay, sorry, can you give me the square root of 0.01 one more time for number 9?
0.1.
Sorry? 0.1?
0.1.
Okay. Can't find my calculator. Oh, there it is. Okay. Sorry.
They want the sample proportion is. So we have so we take the amount divided by the n. So the or the whatever it's called.
Okay.
Very mathematical terms right now. Okay, so we take. So I think x is the 35, and n is 100. We want to know what 35 hits. So 35 over 100 is 0.35.
Oh, yeah, that makes sense. That's the probability. Or the proportion. That's the proportion,
That's
sorry.
Yeah.
More
Okay, and then what is the standard? What is the standard deviation of that? It would be, so it's going to be 0.3 times 1 minus 0.3 divided by 100. And that gives me 0.0021, and the square root of that is 0.045826. So my answer would be
0.046.
Yep. I got.
Okay, so I have a question about number 10. They want P, which is the sample proportion, correct?
Correct.
So we said 35 out of 100. Okay, I got confused because they had the word probability up there, but that wasn't in the actual question. Okay. But then the standard deviation of P. Okay. And you said it was 0.046.
Yep.
Okay.
Okay, give me just a second. Okay, we can move on. I'll figure it out later. For some reason, I forgot some of the functions on my calculator.
They want us to find the z-score. So that is the sample proportion minus the sample proportion minus the true proportion, and that's divided by our standard deviation. So I got 1.091.
Me too.
And one.
Yeah, 1.091.
Okay.
Because we said P was 0.3 and P caret was 0.350.
Yes.
Oh, so we have to do 0.35 first.
Correct.
So 0.35 minus 0.3 divided by 0.046.
Right.
So I got 1.087.
That's what I have.
Okay. So we all good there?
Yeah.
Yeah.
Okay, what is the probability Brittany gets at least 35 hits in her next 100 at-bats?
So we put that in the probability applet.
So 1.0.
Okay. And that's just the normal one, right?
Yeah, I think.
Yeah, it's a normal probability.
At least 35, so this needs to be only the right.
Right. Yeah. So I'm getting 0.139.
Me too.
Me too.
Yep, that's what I got.
Great.
Okay, sweet. Moving on. Number 14, if the true proportion of people who support a political candidate is P equals 0.52, and if N equals 2,000 people are surveyed, we want to determine the probability that the result of the survey will suggest the candidate is losing the election. Gets less than 50% of the votes. What is the standard deviation of the sample proportion? So we are going to take, let's see.
0.52 times 1 minus 0.52. Over 2,000.
I got 0.011.
That's what I got. Or 10. Would it be 10 instead of 11?
I got 0.11.
Oh, okay.
That's because I'm doing it on Excel. So
Okay, I
do all
got
my
0.0096, which would round up to 0.010.
okay. Yeah, I think that's. I asked the teacher once, and he said that the answers accept like a range, because some people use that SPSS thing.
Right, which is a little different.
Yeah, some people use calculators, some people use Excel. I always use Excel because I can see the numbers easier.
Yeah.
But, yeah, so there's like a range. So yeah, I think 0.010, 0.011 is pretty close.
Okay.
Yeah, I have 0.011.
Okay.
Okay, perfect. So that looks good. Okay, what z-score would you use?
Standard deviation.
So let's see. I want to say, so to find the z-score, we do the value minus the mean, so the true proportion minus the sample proportion divided by the standard deviation. So would our true proportion be 50%? or 50? 0.50, I mean.
Maybe. Yes, I think so, because that's what we're comparing, correct?
Yes.
Right.
So I have 0.5 minus 0.52 divided by standard deviation 0.011, and I come up with negative 1.790.
Hold on, which numbers? So you're saying 0.5 minus 0.52 divided by 0.011?
Yep. Yeah.
Okay, I'm getting negative 0.818.
Me too.
Are they probably different because I'm still using the long form of all of them? None of them are rounded.
Oh,
Because like instead of using 0.011, I used 0.011171.
okay.
Well, let me see what happens if I do that. 0.01171.
0111. So there's 3 ones and then 7 ones.
And let me see if that changes anything. And I'm getting 1.790.
That's what I'm getting with that too.
So what were you getting, Tyler?
That same thing.
Okay.
Okay. So then what is the probability the survey results will show the candidate is losing, even though the true proportion is 0.52? So we plug that z-score into the applet, right?
Right.
Yeah. I just want to make sure Kelton's with us. I haven't heard him comment in a while.
No, I'm here. I'm just trying to follow along with all the equations and stuff.
Okay.
So
Do we need to slow down?
no, you're fine.
Okay.
So we plug the 0.790 into the applet.
Yeah.
1.79.
1.7.
Oh, 1 point. Okay.
So which part is shaded if it's less than?
It'd be only the
Isn't-
left half, I think.
Yeah.
I think that's right. I always do that, but I think that's correct. So that would be 0.037.
That's what I have.
0.037. Okay. Everybody got that?
Yep.
Okay, let's start from the beginning. So number 3 is each slice represents a category. Number 4, the only difference between a bar chart and a Pareto chart. Number 5 is true proportion. Number 6 is the sample size. Number 7 is 4. Number 8 is 0.4. Number 9 is 0.1. Number 10 is 0.35. Number 11 is 0.04.
Oh, sorry. It says 2 decimal places on that one, doesn't it?
Yeah.
So 0.35 for number 10.
Mhm.
Yeah.
Okay.
It
And
would
then
take out a
11 is-
0 if you added that in anyway.
Right.
Yeah.
Oh,
0 before the point as well, it takes it out. So,
okay.
so 0.046 is number 11. Number 12 is 1.091. Number 13 is
Wait, sorry, number 12.
Number 12 is
1.91.
yeah.
Is that
You
one
might have-
a little bit different answers on?
You guys might have got
Yeah.
like 1.08 something.
I have 1.087.
Okay, that's what I have too. Okay.
Okay.
And
I'll
then
change it to 91.
I
It's
think 87 would be-
1.091.
Yeah. Okay, number 13 is 0.138. Number 14 is 1.
Okay, for number 13, I had 0.139.
That's what I had
Yeah,
too. But it'll probably be
Yeah.
close enough.
Okay.
Just the way our calculators are calculating.
Okay.
Okay, number 14 is 0.011. Number 15 is negative 1.790. And number 16 is 0.037.
Okay.
Kelton, did you
Did it.
get all of those?
Yeah, I did. I had a quick question though. So, for number 16, I know we used the applet, but where did you guys plug the negative 1.790? Was it on the negative side? The
It
bottom?
doesn't matter. You have to hit enter and then it goes on both sides. And then we highlighted the left side.
Okay, cool. I put a different number in. So yeah.
Okay. So we're going to submit.
Yeah.
Okay. One wrong. So number 7.
Yeah, that was the one we had questions about.
So your answer is probably right, Suzette.
Which one? The 10
What was
point?
her answer?
It was something like 13 point something or another, or 14.
Okay.
I have to look that up.
Yeah, let's look it up and I'll text you guys what I find.
Okay.
So,
Okay.
Sorry about that, Suzette.
No, that's fine.
I thought it was 0.4, or I thought it was 4 as well. So,
Yeah.
okay, so we good?
Yeah.
Yeah.
Nice
Awesome.
and
We
short.
got.
Yeah, thank you so much.
So look forward to Wednesday then.
Woohoo.
Oh, I was going to say, did you guys read the email about how we have to work on a group project?
Yes.
All right.
Oh, I did.
And that is due Saturday. The design your study part is due Saturday.
Yeah.
Okay.
So what I was thinking was maybe we do a just study some other people's research, like ask a question and then go into some research that's already been done and find the data.
Okay.
I mean, we could conduct a survey or some kind of random test or something, but I think that would take longer and
It would be hard to get results back too.
right, and it would be hard to get more than 30 so that it would be
Accurate.
yeah.
Especially in such a short amount of time. If we had a couple weeks, that would be a little different.
Mhm.
Right. So I was looking online and data. That's like you could just look up statistics, you know.
Mm-hmm.
And my husband was saying, you know, there's a lot in the census. Like we could just study the census from some year and ask like what percentage of households had I don't know, head of household under the age of 20 or over the age of 60 or you know, anything really. And then all we have to do is find the data, look at it, and go from there. But all we have to really do this week is just say, here's what we're going to study.
Right.
Yeah.
I like it. I think that consensus idea is a super good idea.
The census?
Yeah, because that, I mean, the data's right there. We wouldn't have to do a ton of research. We literally.
Right. Okay, so what we have to do is we have to pick a year. We have to pick, you know, like a state or whatever. But I don't know, maybe that's something we can do a little work on tonight and then text back to each other.
Yeah, that sounds great.
Okay.
Yeah.
So maybe look up a census, try and find an idea of what would be useful.
Right.
Sounds good to me.
Okay.
Okay, so we good?
I think so.
Yes.
We'll text each other tomorrow about the census.
Okay.
Awesome. Sounds good. Talk to you guys later.
Thank you.